how we can apply in space science and military uses?
Yeah, it gives the speed. Speed enhancement is the basic thing. So, if it is user friendly for defense application, if it has to be field worthy, then we can take it on for the defense applications. And the moment we get an enhanced speed capability, and if our structures, the temperature withstanding structures are there for the aircraft, we can use it for any application, space travel.
Ma'am, one more question. Why we cannot use stainless steel for the making missiles, because it is very durable? For example, you see SpaceX companies launching this rocket which is using for structure stainless steel.
Yeah, the launch vehicle, like satellite launch vehicle, doesn't bother for this weight optimization. Here I am looking at missile application, it's for a range capability. So that is where this weight optimization more comes into. We look for the composite structures like Kevlar or carbon fiber systems. So that gives the weight benefit. As I mentioned, 1 kg extra, I lose a range capability of 4 to 5 kilometers in this class of missiles.
Thank you so much, ma'am. Thank you so much.
India is going for Gaganyaan mission. India is making a footprint in globally. So how do you see Elon Musk, SpaceX contribution in space, and how we are into what is the benchmarking?
Yeah, Elon Musk has gone a long way as compared to, as our space missions are concerned. We want, as India, as a country, developing country, we want to take our astronauts to the space station. So that's why we are going for the Gaganyaan. Then step by step, definitely, we started on the space technologies only by 1970s and all. So whereas US, the country, is having hundreds of years of experience. So that makes the difference. But as technology and the accuracy of the systems what we use, we are at par with the world class.
Thank you.
Ma'am,
Yeah.
how many types of missile?
Types of missiles are plenty, like depends on the applications, as I mentioned. Can have tactical missiles from 300 meters to strike an object or incoming missile. 300 meter onwards we have the potential. So 300 to 5,000, and plus it is a addition of stages of rockets. So any range capability we can do.
Thank you.
Yeah. Thank you.
Ma'am.
Thank you, Dr. Thomas, for giving such a enlightening talk, and I can see like kids also enjoyed. You have given a good overview of state of affair, current. One more.
Good morning, ma'am. I'm from class 9. I would like to know that in future, how will AI will reduce human effort in launching or making a rocket, or it's doing now?
Yeah, definitely, because AI is going to give us an aided tool, intelligence tool. So wherever we can take up the automation, like in launching also, today missiles or aircraft, let's say, it's not vertical takeoff. The autonomous takeoff, the area in which the airport area also comes very limited aerospace is required for takeoff and landing. So such as those type of things can get through artificial intelligence, vertical electronic and vertical takeoff of the aircrafts. Even commercial also, we need a big long runway as on today. But if the vertical takeoff type of systems comes, the runways can become less than half also.
Thank you, ma'am.
Okay, thank you, Dr. Thomas. We can see like kids has so many questions. So definitely they have enjoyed your lecture. Thank you. So next we are moving to first plenary talk on space weather and impact on space technology by Professor Dipankar Banerjee. He is currently the director.
You are changing my slides.
Okay. No problem, sir. We will
Just
do
go
it.
back. Yeah.
So he is currently the director of Indian Institute of Space Science and Technology, Thiruvananthapuram. And he is also former director of the Aryabhatta Research Institute of Observational Science, Aries, Nainital. So let it be settled, sir.
Yeah, they have schedules. Yeah, we are running late. So it's okay.
Okay. So, Dr. Dipankar is an astrophysicist with a bachelor degree in physics from St. Xavier College and master degree in theoretical physics from University of Kolkata. He is also a senior professor at Indian Institute of Astrophysics. Now, Dr. Banerjee area of interest is sun and the solar atmosphere. His work involves theoretical and numerical modeling using data from ground and space-based instruments. His work has enriched our understanding of the sun and its impact on space weather. He is the co-chair of science working group of the Aditya L1 mission. Aditya L1 is the first dedicated mission, Indian mission to study the sun. And Dr. Banerjee has more than 160 peer-reviewed publication. He is guiding. He has guided already 17 PhD students. And one more interesting thing, apart from the scientific area, Dr. Banerjee has interest in various other activities. He is trained in Hindustani vocal and part of Bengali theatre group. And he performed and participated in national and international theatre festivals. So with this, let's welcome Dr. Banerjee.
Thank you very much for this opportunity. I see the students have different schedules, so we are running late. So probably they have been already asked to attend some other session because of the time. So thank you, my colleagues. Students, I want to know how many of you are 11, 12 students? Raise hands. There are a few. 9, 10? Okay, more 9, 10. So okay, I will pitch my lecture to that level. So that's why I wanted to ask this question. So you heard that we have many space assets today. Huh? So we have aircraft, we have our own satellites, we have our missile system, but then we have to save these assets also in space because the trajectory of these assets gets heavily affected what is happening in the sun. So sun is our nearest star, the Surya Devta, and as you see here, this is sun. And this is the space between the sun and earth, and because of activities which happens in the sun, in its atmosphere, this space is heavily affected. And there are sometimes very dynamic events happens, there are huge energetic explosions happen, and as it travels, it directly impacts the satellites gets damaged, so that's the area called space weather. I don't know how many of you have heard about this term space weather. Probably not many, but this is becoming increasingly more and more important in our modern day life. I'm sure when we were young at your age, in the morning if you go to the seashore, you will see that the fishermen will hear, also listen to the radio, and see that whether it is safe to go to fishing in the sea. Today what is happening is if an aircraft has to launch, then the space companies have to ask solar faces like us, is there anything happening in the sun? So that my satellite will be saved. Incidentally, there were 39 satellites were destroyed just 1.5 years back. You heard about SpaceX. So Mr. X ignored this solar explosion and he lost his 37 satellites. So we cannot afford in modern day that. So I will be talking about that. We have to save our humans also. Before I go, I just wanted to very briefly tell you about the institute I come from. Yeah, again, let the students move to the next session because they have, I think. So I come from this institute called Indian Institute of Space Science and Technology. This is the academic wing of ISRO. If you want to join in ISRO, but maybe not many, then this is the entry point. If you clear advanced JEE, so this is the institute where you have to come for undergraduate program to get into ISRO's, permanent job positions. So I will probably, just skip a few slides because, I thought, I will have more, students from high secondary, because we run this BTech program, aerospace engineering, electronic communication, then there is engineering physics, of course, all the other subject areas are also heavily required for understanding the, aerospace engineering. So that's the sort of, milestone to get into ISRO's program. And now, today the other important element for some of you, probably you are not fully aware, space has become open now, in the sense there are a lot of privatization which is going to come in coming years. So there are 200 startup companies come registered in 1.5 years. Just 1.5 years, there are 200 startup companies for space domain has been opened because of the new government policy. You can have your own company, you can have your own launch vehicle, you can have your own satellite. So this is a really fantastic new opportunity which was not there in the past. So I hope not many youngsters are still remaining, but be aware, you can sort of pass on this information about this institute. So I will quickly forward these slides, but let me get into my subject area, which is the sun. So here you see the solar atmosphere. We think that the solar atmosphere, our sun is always emitting, fixed intensity or fixed luminosity energy, but it is not true. There is a lot, very slight variation in the solar output. We call it luminosity, and that has a periodicity of 11 years. So that does affect, our atmosphere and our climate as well. So our climate is also completely governed by solar radiation, we all understand. So that's a long-term variation, but we also have these kind of huge explosions which happens in the sun, and that emits, we call it coronal mass ejection, huge amount of coronal material with the magnetic field and all that is thrown into the interplanetary space, and that travels in the interplanetary space. So this is a movie from Parker Solar Probe, one of the NASA mission. And I'm sure this is not a very nice environment to roam around. So this is what I'm talking about is called the space weather. And we are now tracking these explosions all the way from the low atmosphere of the sun. This is called corona. Incidentally, you can only see the solar corona during the total solar eclipse, right? I don't know how many of you have seen a total solar eclipse. Yeah, Dr. Leonardo has seen many, I know. So that's a celestial miracle almost, that the moon comes between us and the sun, and we get the perfect shadow of the moon, and we could see only during that time the atmosphere of the sun. Otherwise, we see only the surface of the sun, and majority of this activity happens actually in the atmosphere of the sun, all the huge explosions we are talking about. So here we are trying to artificially block this solar disk, creating a total solar eclipse kind of situation from space. Those instruments are called coronagraph. Incidentally, in our own Aditya mission we have such an instrument. And then we try to track these ejecta as they travel to the space, and this region we call it heliosphere, and this is the near Earth environment. So as you can see that it is important to understand that when these ejecta will arrive in the Earth, how it is going to impact our Earth's geoeffective environment as well. So this particular domain is called the space weather. I will try to spend a few minutes here. So, this is, Earth's atmosphere. Ionosphere is one of the atmospheric layers which are very important for our communication system. Majority of our satellites are actually in this, region. So, if a solar storm happens, then it will disturb this ionosphere. And when the ionosphere is disturbed, all your communication systems can be directly affected, or your WhatsApp will not be delivered for a few hours because one of the satellites is actually damaged and completely out of functioning. there is another very important thing happen is, you know, all these space assets what you heard, even Madam showed all the projectiles, they are going through a medium. So there is a drag which has to be always calculated. So your trajectory is crucially dependent on the density structure of the atmosphere. But when such a solar storm happens, your atmosphere gets completely disturbed, and your atmospheric drag will be very different. So why SpaceX launched their satellite, but it was not a direct impact of the solar storm on the satellite, but he did not include the effect of the atmospheric drag change into the satellite trajectory. So the satellite never could reach 400 kilometers, it only reached up to 200 kilometers and then fell down. So similarly for all our space missile systems, also this is a very, very important. That's why we solar scientists are now very important for DRDO's research as well. And there are going to be dedicated space weather missions actually now. So that's one area. Of course, we are talking about going into space. Humans going into space, they are going to be directly impacted by these highly energetic particles. So that's really a very, very big concern. A lot of bio effects need to be studied. So that's what happens in our laboratory. We get a direct impact of the electric grid disruption, because when these energetic particles interact with transformers, they create induced current, and that shuts down the power system. In fact, in northern hemisphere, particularly in Canada, this happened. Quebec had a power shutdown of several hours in a winter, and that closed down all the metro systems and the air conditioning system and all that. And apparently the insurance claim was about $100 billion. So that's actually a real now big requirement to predict these huge impact when it is likely to come. Then we can think about protecting this system. Mitigation plans can be written on. Of course, this radio wave disturbances and the communication systems get dragged. Solar cell directly gets impacted. Of course, space assets means most of the satellites are completely dependent on the solar power. And the solar power, if they get damaged, then your satellite's life is completely directly impacted as well. So there are a number of such impact, which is now really of a big concern for a modern space-dependent society. It's just not Earth alone. I'm just showing that we are talking about other planetary atmosphere. So if you want to have a colony in moon, you want to go and land in moon, and if there is a solar storm, actually that person is in great danger. So now we are essentially from the space going to different planets, having orbiters, having landers, and they're monitoring the solar radiations, and it's this kind of a huge impact. So these are simulations that predicts when such a big CME will arrive at different planetary locations. And in fact, the life on these planets are also only dependent if the Earth or this planet has a magnetic field. Here again I'm showing, I did not talk about so much yet, we are actually existing in Earth because of Earth's magnetic field. If Earth did not have a magnetic field, we would not have existed, because that is providing the cocoon. We are living within that cocoon. So if a planet will have a life is really crucially dependent on whether the planet has a magnetic field or not. So here there are now a lot of simulation work is happening within India as well, because we all are interested to know about the presence of life in other planets. There are 5,000 odd other planets been discovered in other sun-like solar systems in other our neighborhood and other galaxies, and all of the basic criteria comes whether the planet has a magnetic field or not. So here these simulations show you how these kind of solar storms will impact our any planet's environment. And in a real time now we are monitoring sun with multiple vantage point, with multiple instrument to really predict when such a storm is going to happen, and if such a storm happens, then what kind of propagation or the kinematics that storm will happen, when it will reach at different point in space. So it could be a satellite in space, it could be a human in space. There could be also long haul flights which are directly affected. I didn't point that out. You take a flight from Delhi to New York now, it takes a polar route. When it takes a polar route, basically it is going to the high latitude.
these highly energetic particles, they are bit deflected by Earth's magnetic field. But what happens is, because of this Earth's magnetic field, these particles, they come this way and they try to penetrate through the polar region. That's why you see auroras. You know, polar auroras and all that is seen, particularly when sun is, magnetically very active, means more storms. So here, if you are flying through this region, you are directly impacted by those highly energetic particles. In fact, there should be statutory warning given by all airlines who are taking polar route, particularly for pregnant women. It is absolutely no, because the amount of exposures or cosmic ray hits these individual bodies are bombarded with, there is no calculation. So this is going to come now. This kind of statutory warning will come. So the space weather for modern world is a reality. We are slightly late. We have to now really wake up very soon, because we are so much dependent on space technology. So whether you call it communication, whether you call it defense, every sector, it is, the space assets have to be protected. And for that protection, the variability of our nearest star, the sun, has to be understood very well. So it is a really global phenomena. The global scenario, they do these kind of simulations, and as I was saying, they combine observations from Earth, combine observation from different vantage point in space, because there are n number of satellites. I will showcase you. I just wanted to highlight here that this is such an important field for the next generation, and it is a multidisciplinary field as well, because you need geomagnetic experts, you need solar experts, you need aerospace engineers. So it is really a multidisciplinary field. This is a lot of effort is going on in US front. Obviously, they wake up much earlier, and even from Europe. So what is I'm trying to show is that you have observations from the sun, we have observations from space-based coronagraph, observations of aurora. When these particles arrive at the different northern or extreme polar regions, then they combine these observations. They also combine all the cosmic ray fluxes, Earth's magnetic field changes. There are momentarily impact on Earth's magnetic field. So our Indian Institute of Geomagnetism, it has centers all across India. So they do measure. Incidentally, the big storm in more than 150 years back, it's called Carrington Map. It's only one record globally available. That is from Bombay. Only record of a geomagnetic storm as recorded, from an official scientific instrument is actually from India, and it happened in, from Bombay IIG center. So I think this is the way forward. It again needs a lot of interaction. I'm just again showcasing this is an area where really the partnership between academia and industry is very important, because industry also has a lot of computing resources. They have all these satellite domain, and so as you can see here, Lockheed Martin makes you know what Lockheed Martin makes, right? So they make defense equipment. So advanced space, these are defense companies. These are again private companies who are into solar research, and of course NSF, NASA. They are all working together towards this. So this is an area which really we need to now wake up from Indian context as well. Very small way we have started it from one of the ISER in Kolkata. So there is a solar flare forecast, activity cycle prediction, and the surface magnetic field. As I said, all these huge ejecta is because of the instabilities of the magnetic structures on the sun. So where these magnetic field evolutions are happening, understanding the magnetic field changes and then its energy content and all that is very important to be found out. So space weather from Indian scenario, as I said, satellites, Gaganayan, is such an important thing. We have to think about our own people going into space. Indian Space Station you have heard about. These are milestones which have been set by our Prime Minister. So we are going there. There is no other way. So that means we have to work towards protection this deep space mission, moon landing mission. So this is again it's not a dream anymore. It's a reality. So we have to prepare ourselves, and for that understanding the sun is very important. Of course, we have traveled to L1. So this is the mission which I have been involved in more than 2 decades now. It's a multi-institutional, effort. This is again a reasonably good, I think, example of all academia institutions along with ISRO working together. This is again complete Atmanirbhar Bharat, because all the instruments are built within Indian, laboratory systems. But I just wanted to highlight that that many satellites are there in space actually from different international space agencies. That many satellites are there just to study the Earth and Sun planetary system together. So we call it heliophysical sciences. And to understand that, as I said, you need multiple vantage points to combine your informations to this. We have started late, but we have started with a bang, because we have gone to a location called Lagrange 1, which is directly in the Sun-Earth line, 1.5 million kilometers away from Earth. So anything comes from the Sun before it reaches Earth, or assets in our neighborhood, has to pass through Lagrange 1. So we have a combination of remote sensing instrument and in situ instrument. It will allow us to study the space weather effects very well. I would like to only also announce, this is my last but one slide, day after tomorrow, we are launching a mission called Proba 3. This is a technology demonstration mission of European Space Agency. The interesting thing is, European Space Agency thinks also ISRO is really capable of partnering. So we are launching it our own polar launch vehicle from Sriharikota, this technology demonstration satellite from Europe. So I think, ISRO, you all know that has really established its credibility, but now agencies like NASA and ESA are really considering us to be a viable partner to have a mission of this nature. This is a very, very challenging mission. It's called, formation flight. The idea is there are 2 satellites going into space with PSLV with a very highly ecliptic orbit. So the farthest distance is almost 60,000 kilometers, and the near distance is about 500 kilometers. So it is really, really highly elliptical orbit. The first satellite is going to cast a shadow of the solar disk on the second satellite. So you see here again, it is a mimic of the total solar eclipse. When total solar eclipse happens, the moon casts a umbral shadow on Earth, and if you are in this deep core, we call it umbra, you see totality. If you are not in umbra, then you do not see the totality, you see only partial phases of this. Here, the target is these 2 satellites are going to be separated by 150 meters, and the accuracy they need for formation flight is 1 millimeter. 1 millimeter in space. That's how they steady these 2 satellites has to be. Of course, this is laser technology, laser tomography and all that other things will go. India is partnering the LIGO experiment also, so with those things also it will be very helpful. So here they will only have 6 hours of this kind of formation composition out of one full orbit. And we are partnering with them, so they are all, about 100 Europeans are already landing today. And the launch is scheduled on 4th at 4:08 p.m. So I hope some of you will be, seeing us. Chairman is also coming today, but he is also going to fly back to Shar for this preparation of the launch. So my point is that we are really, really, from the space, we are going into the most advanced technology of global in nature, and our safeguarding our own space assets, and also partnering with other, global scenario is need of the hour, and that we can't do it, alone. We need many more people. Unfortunately, the young people have disappeared, but please, try to motivate them more so that, we can really achieve this kind of target. And thank you for your attention. Yeah.
It's quite interesting lectures. What I was just looking, I'm a hydrologist working for Brahmaputra rivers and all, looking the data of last 150 years and fall data and all. I also got a periodicity of 11 years. do you believe that most of the hydrologic phenomena is controlled by this 11-year periodicity?
So definitely there is an impact of, so what exactly you are measuring?
From the rainfall data, so what 150 years data, we are looking the time series periodicity of wet years and the dry years.
Yeah.
That periodicity is also coming close to 11 years.
Yeah. So there is a sort of report of this. I mean, I did not talk about, I actually work with the Kodaikanal archival data, and
Yes.
I work a lot on the solar dynamo and all that.
Yes.
So I must say that the correlation is found of this 11-year periodicity with many different things.
Yes.
The cosmic ray fluxes, the luminosity, what I said, and all that. So there are demands that the rainfall record does show, some impact also.
Yes.
So this is a little bit of controversial subject. Some people do find there are, pretty well established journal articles
Yes.
on this.
Yes.
But there is a, because the sun does these things in a more of a global scale.
Yes.
So whether you can, this local, parameters, you can
Yes.
reflect to a global phenomena and all that, is still an open question.
Yeah.
But it is true that people have reported that in many, many important journals.
And how could be Jagannath temples have a 22 steps? So did you believe that 100,000 years back they understood the sun more than us?
In fact, this is, since you asked this question, India is one of the oldest cultures. We knew about the sun and its behavior really, really well. Think about Konarak temple.
Yes.
There are, you say Jagannath temple, or I will say Konarak temple, because Konarak temple is a sun temple.
Yes.
In fact, Uttarakhand,
Yes.
there is a 9th century, temple. I personally studied that,
Yes.
which is called a Katamal temple.
Yes.
All these temples knew the movements of the, solar, sun movement. So they precisely one location on the summer solstice and winter solstice where the solar positions will be, they knew. So the light rays used to come through a little hole and go directly into the Garbhagriha.
Yes.
So that information they had.
Yes.
So my point is positional astronomy. So the
Okay.
stellar positions, all the different constellations and all that, that knowledge was there with all, old civilizations.
Yeah.
So, and India is one of the oldest civilizations. So that is very, very true that we had a clear understanding about, different planetary positions, constellations. So that's how, majority of our mythological stories are based on those.
Okay.
Because they did have some knowledge
Yes.
on that.
Thank you, sir. Thank you.
Thank you, sir. It was a wonderful interaction. I wanted to know two things. First, we predict the space weather. How do we save any space objects that way? Like
Yeah.
prediction is one part and saving is one part. How do we do that?
So very, very good point. So the first is you have to understand when the source region explodes. Then is that, the source, this material, when they can arrive. Third is a mitigation plan. So typically we do not have too much of, room now. We can close down some of the, operations to safeguard. So that's the best thing which we can do. Changing the such trajectory and all that will also depend on how big these magnetic clouds are. So they're like, when a cyclone comes, what all region it can affect, we do some prediction from the global maps and all that. We say, this yesterday's thing in Chennai, it did have a little effect even all the way here. I mean, we were cloudy, very, very cloudy, day before yesterday here. So this kind of huge, when this front comes, how big is that front and which direction it is coming from? From there, if there is a possibility, we can change the trajectory a little bit. But that demands a lot more use of thrusters and all that as well. So the best thing